Hello everyone, I am Balaji Rao. Welcome to BR Max class. Till now we completed 7 models in integration chapter. In last class we done exercise number 7.6 problems from class 12 integration chapter. In this class we will do integration by using partial fractions. In this class what are the things we are going to learn? Till now I said we completed 7 models. This is 8th model, model number 8. What is this model number 8? Integration by using partial fractions. In NCERT textbook, all these problems are there in exercise number 7.5 class 12 integration chapter. Okay. So integration by using partial fractions. In this class, I'll explain what is rational function, what is proper rational function, what is improper rational function, how to convert proper functions into improper fractions, how to convert proper fractions into partial fractions. And in this integration by partial fractions, total 4 types of problems are there. First one, when the denominator contains non-repeated linear factors, how we write that rational function into partial fractions. Second one, when denominator contains repeated linear factors, then how we write that rational function into partial fractions. Like that, total 4 types are there. I don't want to confuse you by explaining all types now only. In this class, I'll explain what is rational function, what is proper fraction, proper rational function, improper rational function, and we'll do type 1 problems in this. What is type 1 and what type of problems comes under type 1? And in this class, I'm going to do 5 problems. 1, 2, 3, 4, 5. Total 5 problems I am going to do in this class. Without much delay, let's begin. Okay, model number 8. Integration by using partial fractions. Many students, they confuse to do these problems, integration by partial fractions, because they will confuse how many types of partial fractions are there. So to avoid that confusion, I divided this exercise problems into 4 types. In today's class, we are going to do type 1 problems. First one, what is rational function? What is rational function? We learned this in class 11 functions chapter. You observe here, a function is of the form p of x by q of x. You look here, all the examples, p of x by q of x, p of x by q of x, p of x by q of x, p of x by q of x. A function of the form p of x by q of x, where p of x and q of x are polynomials in x. P of x, q of x are polynomials in x, and denominator q of x is not equal to 0. A function of the form p of x by q of x, where p of x, q of x are polynomial functions and q of x not equal to 0, are called rational function. What you learned? Rational function. You see, these are the examples for rational function. Rational function examples. In rational function, 2 types of things are there. This is very, very important what I am saying now. One is proper fraction. This is most important. More clearly, proper rational function we will say. What is proper rational function? This is rational function. Which one is? This is rational function. Which one is called proper rational function? Look here. If degree of p of x, you can observe this. If degree of p of x is less than degree of q of x, degree of p of x is less than degree of q of x, then that rational function is called proper rational function. This is important. Then the rational function is called proper rational function. What is proper rational function? If degree of numerator is less than degree of denominator. Degree. For a polynomial function, you can easily identify how to identify degree of polynomial. Look here, this example. Please observe this example. What is degree of numerator? This is a linear function whose degree is 1. Okay, you observe this denominator. What is degree of this polynomial function? When I multiply these 2 things, I will get a quadratic expression. X square will be there. That means degree of this expression is 2. Okay, you observe this one. What is degree of this numerator 3x minus 1? Degree of this is 1. What about degree of this one? Denominator. What is degree of denominator? Yes, degree of denominator is what? When I multiply, you will get a cubic equation. A degree of denominator is 3. So you know how to check the degree. Okay. What I am saying here, what is proper rational function? This is most important. What is proper rational function? If degree of, in this rational function, if degree of numerator, degree of p of x is less than degree of q of x, then it is called proper rational function. You look here, otherwise it is called improper. This is important. In partial fractions, you must know what is proper rational function, improper rational function. You must know. Here you observe this one. It is proper rational function or improper rational function? Answer, please comment. It is proper rational function or improper rational function? Please comment. Degree of numerator is what? Degree of numerator is 1. What is degree of denominator? Look here. What is degree of denominator? Degree of denominator is 2. Degree of numerator is less than degree of denominator. Degree of numerator is less than degree of denominator. Then what it is called? Proper rational function or improper rational function? If degree of numerator is less than degree of denominator, then it is called proper rational function. What is this? This is proper rational function. I hope you are understanding. Okay, you observe this one. You observe this one. Degree of numerator is what? Degree of numerator is what? You please, is this is proper rational function or improper rational function? It is proper. Why? Degree of numerator is what? Degree of numerator is 1. What is degree of denominator? Degree of denominator is 3. Degree of numerator is less than degree of denominator. That's why, what is this? This is the example for proper rational function. I hope you are understanding. Right? Okay. Now you observe this one. What about this one? Proper or improper? This one is proper rational function or improper rational function? What about degree of numerator? Degree of numerator is 2. Okay. What is degree of denominator? Degree of denominator is what? Degree of denominator is 2. 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 Look here. Degree of f of x, degree of numerator is less than degree of denominator. It is called proper rational function. If degree of numerator is same as the degree of denominator, look here. Here degree of numerator is 2. Degree of denominator is also 2. What is this third one? If degree of numerator is less than degree of denominator, then only it is rational. It is proper rational function. Otherwise it is improper. They mention otherwise it is improper. So here degree of numerator is not less than degree of denominator. Then it is improper rational function. This is the example for improper rational function. I hope you are understanding. Very simple. Degree of numerator is less than degree of denominator. Then it is called proper rational function. If degree of numerator is greater than or equal to degree of denominator, then it is called improper rational function. You observe this one, this example. This is a proper rational function or improper rational function. You observe here, what is this? This is proper rational function or improper rational function. Degree of numerator is what? Degree of numerator is 3. Correct? What is degree of denominator? Degree of denominator is 2. That means degree of numerator is greater than degree of denominator. So this is the example for improper rational function. So we learned what is rational function. A function of the form p of x by q of x, where p of x, q of x are polynomial functions and q of x not equal to 0 is called rational function. When we say a rational function is proper rational function, when degree of numerator is less than degree of denominator, then we call it as a proper rational function. When we call a rational function is improper rational function, when degree of numerator is greater than or equal to degree of denominator, then we call it as improper rational function. Okay, now we'll move to problems. To understand this integration by partial fractions clearly, I divided these partial fractions into 4 types. We'll try to understand what is type 1. Look here, type 1. What is type 1? First thing, it is proper fraction. Proper fraction. We can say proper fraction. In some books they will say proper rational function. Both are okay, no problem. Actual NCERT textbook wording is it is a proper rational function. Okay. First thing, what is type 1? First of all, the given function must be a proper rational function and denominator contains non-repeated linear factors. First thing, you observe, it is proper or not? Degree of numerator is what? Degree of numerator is 1. Degree of denominator is what? Degree of denominator is 2. So degree of numerator is less than degree of denominator. Yes, it is a proper fraction. Observe this one. Proper fraction or not? Degree of numerator is what? Degree of numerator is 1. Degree of denominator is 3. Degree of numerator less than degree of denominator. So this is example for proper fraction. Okay. Degree of numerator 1. Degree of denominator 3. It is proper rational function. Look here. Degree of numerator 1. Degree of denominator 2. Degree of numerator is less than degree of denominator. So this is example for proper rational function. Look this one. Degree of numerator 1. Degree of denominator 3. Degree of numerator is less than degree of denominator. So this is a proper rational function. So whatever examples are there here, they are all proper rational functions. First point. Second one, denominator contains non-repeated linear factors. Linear factor means what? Like x minus a, x minus b, 2x plus 1. All these are known as linear factors whose degree is 1. Okay. So denominator contains non-repeated linear factors. You observe this one. Denominator contains non-repeated linear factors. X plus 1 repeated anywhere? No. Only once x plus 1 is there. X plus 2 is a linear factor. It is not repeated. So denominator contains non-repeated linear factors. So to use integration by partial fractions, first thing you need to identify by seeing the question. Here what type we are doing? Given function is a proper rational function and denominator contains non-repeated linear factors. Look here. It is a proper rational function. What about denominator? X minus 1 repeated. Is it a linear factor? Yes. Is it a linear factor? Yes. Is it a linear factor? Yes. And x minus 1 is repeated anywhere? No. So it is a non-repeated linear factor. Non-repeated. X minus 2 repeated anywhere? No. X minus 3 repeated anywhere? No. So what is this? Denominator contains non-repeated linear factor. Look here. Denominator contains non-repeated linear factor. You observe this one. Here denominator contains non-repeated linear factors. I have a doubt in this. So what I'll do? Okay. Look here this one. This one. You observe this one. First thing, it is a proper fraction. Now my question is, denominator contains non-repeated linear factors. Actually this is quadratic expression. So x plus 3x plus 2 is there na? Denominator, I'll check it. I'll write this into linear factors. I'll try to split the middle term. I'll try to write it into linear factors. This 3x is there na? 3x you write in the form of 2x plus x. Then you will get like this. 2x divided by x plus 1 into x plus 2. I can write like this. Look here, multiply x square. Here x square is there. 2x plus x, that is 3x. 1 into 2 is 2. Now, you observe this one. First thing, it is a proper rational function. Second point, denominator contains non-repeated linear factors or not? Yes, denominator contains non-repeated linear factors. Now, you observe this, this bit. Proper fraction, proper rational function or not? Yes, it is a proper rational function. Denominator contains non-repeated linear factors. Actually, at this point, you cannot say here quadratic factor is there. I'll write one more step for this. This can be written as 5x divided by x plus 1 into, look here, x square minus 4 is there. Na? This 4 can be written as 2 square. It is of the form a square minus b square. So formula is a plus b into a minus b. So this can be written as x plus 2 into x minus 2. I hope you are understanding. Now you observe, it is a proper rational function and denominator contains non-repeated linear factors. X plus 1 not repeated anywhere. X plus 2 not repeated anywhere. X minus 2 also not repeated anywhere. I hope you understand what are first type problems. What are first type problems? What is first type problem? First of all, it must be a proper rational function. Look here, proper rational function. Second one, denominator contains non-repeated linear factors. So these 5 problems I am going to do in this class. Okay. And very, very important. Very, very important. When it is a proper rational function. Look here. When it is a proper rational function. I forgot to write here. How to write this proper rational function into partial fractions. Suppose something is like this. Px plus q divided by x minus a into x minus b into x minus c. Something like this. You observe degree of numerator is 1, degree of denominator is 3. So this is proper rational function. Yes, and denominator contains non-repeated linear factors. So this comes under type 1. When in the question they given like this, then we will write it as a divided by x minus a plus b divided by x minus b plus c divided by x minus c. Here the point is, this is proper rational function. Denominator contains non-repeated linear factors. Then we will write this proper rational function into partial fractions like this. These are the splitting into partial fractions. Okay, so what are the things you need to understand till now what I explained? First thing, you need to know it is a proper rational function, and second one is denominator contains non-repeated linear factors. Then this proper rational function we will write into partial fractions like this. I hope you are understanding. We identified that all these are proper fractions and denominator contains non-repeated linear factors. So then let's see how we'll solve these problems. Actually, total 4 types are there. First type is actually very easy. Let's see the solution for first question. You observe this question, integral of x divided by x plus 1 into x plus 2 dx. First point is it is a proper rational function. Degree of numerator is 1, degree of denominator is 2. Yes, it is a proper rational function, and denominator contains non-repeated linear factors. Linear factors are there here. Is x plus 1 repeated anywhere? No. Is x plus 2 repeated anywhere? No. So denominator contains non-repeated linear factors. So as per the partial fractions, this proper rational function can be splitted into partial fractions like this. How to write this? This is most important. We will write it as a divided by x plus 1 plus b divided by x plus 2. We will write like this. This is the major part. This is the major part. We identified that given question is a proper rational function and denominator contains non-repeated linear factors. Then how to write this proper rational function into partial fractions? Like this we will write. Okay. Now our first target is finding the values of a and b. How to find the values of a and b? Okay. Little bit of simplification I will do here. A divided by x plus 1 into x plus 2 equal to, here what is LCM? LCM is x plus 1 into x plus 2. Okay. Now you multiply these two things. A into x plus 2. You know how to do LCM of all these things. Plus b into x plus 1. Okay. Now look here, this x plus 1 into x plus 2, x plus 1 into x plus 2 will get cancelled. What is remaining? X equal to a times of x plus 2 plus b times of x plus 1. What is my main target here? Initially, I want to find the values of a and b. I want to find the values of a and b. Here, we can find the values of a and b from here in two methods. One is comparing the coefficients on both sides. Second one is just taking some values, some x values. It is a tricky method. We can calculate a value, b values from this in two methods. One is comparing the coefficients. Another one is a tricky method, putting x equal to so and so value. For example, if I want a value, this term must become 0, right? This term must become 0 means, suppose if x plus 1 equal to 0, I will write here, x plus 1 equal to 0. What is x? X is minus 1. So to get a value in this complete equation, I will put x equal to minus 1. One more point here, this equation is true for all real values of x. In this equation, not only x equal to minus 1, in place of x you can write 0 also, in place of x you can write 100 also, you can write 1 crore also. This is true for all real numbers. Okay. So as I want a value, I want to make this 0, so I will put x equal to minus 1. Okay. Put x equal to minus 1. Why I am putting x equal to minus 1? This is a tricky method. If you want a value, you must make this term 0. X plus 1 equal to 0 means x is minus 1. That's why I am putting x equal to minus 1. Okay, put x equal to minus 1. Minus 1 equal to a into minus 1 plus 2 plus b into minus 1. No need to write this b term. Look here. Minus 1 plus 1 is 0 now. Why to write again here? No need to write. I don't write. You also don't write. Okay. Look here. That equal to minus 1 equal to a into minus 1 plus 2 is 1. So what is a? A value is minus 1. I got a value minus 1. Okay. So here I got this a value as minus 1. Okay. Now I need to find b value. What to get b value from this? If you want b value, you need to make this a 0. How it will become 0? Suppose if x plus 2 equal to 0, what is x? X equal to minus 2, right? Put x equal to minus 2 right here. Put x equal to minus 2. I'll put x equal to minus 2 in this complete equation. Okay. Here x is there. In place of x, what I'll write? Minus 2. Okay. Minus 2 equal to, when I put x equal to minus 2, this whole thing will become 0. So no need to write this. Okay. B into minus 2 plus 1. Okay. Minus 2 equal to minus 2 plus 1 is minus 1. So what is b? B is 2. B is 2. I got a value, b value. That is my main intention. I want to find a value, b value. I got it. Now you observe, I'll take this as equation 1. You observe this as equation 1. I'll do one thing. I'll take the same thing. Okay. This is equation 1. In equation 1, what is a value? Look here. Look here. What is a value I got? Minus 1. So I'll replace a with minus 1. Okay. Now you observe here, what is b? B I got it as 2. Now I'll replace b with 2. Look here, this is equation 1. I hope you can see. This is equation 1. This is equation 1. I got this a value, b value. This a value, b value, I am substituting in equation 1. Look here, I got like this. I got like this. Now what is the question? This is the question. I'll take the question. This is the question. This is the question. I want to integrate this. Now what I got here? I got that integral of, look here, x divided by x plus 1 into x plus 2 can be written like this. That is what I got. So in this question, in place of this, can I write this? Yes, you can write. Yes, write it. Write it. Write same thing you write. Okay, into dx. How to integrate this? I'll integrate each and every term. While integrating this, you observe in the numerator minus 1 is there. Minus 1 is constant. You write outside the integral. Minus integral of 1 divided by x plus 1 into dx plus, while integrating this one, you observe in the numerator 2 is there. 2 is constant. Here 2 is there. 2 is constant. Take it outside. 2 times of integral of 1 divided by x plus 2 into dx. I hope you are understanding, right? That equal to minus. You learn this formula. See, this is model number 8. You learn this formula in model number 3. Integral of f dash of x by f of x dx is what? Log mod f of x plus c. Is log mod f of x plus c. If numerator is the degree of if numerator is the derivative of denominator, if numerator is the derivative of denominator, we will write its answer directly. Correct? So here, what is derivative of x plus 1? What is derivative of x plus 1? Derivative of x plus 1 is 1. Correct? So this integral is of this form only. Integral of f dash of x by f of x dx. What is its answer? Log mod f of x. So what is integral of this? As numerator is the derivative of denominator, I'll write its answer log mod x plus 1 plus 2 times of, look here, x plus 2 derivative is what? X plus 2 derivative is 1. X plus 2 derivative is 1, right? This integral is of this form only. Integral of f dash of x by f of x dx. Numerator is the derivative of denominator. Then how you will write its answer? Its answer is log mod f of x, right? This is log mod x plus 2 plus c. So this is the required answer. Let me check correct answer once. A value is minus 1, b value is 2. Very good. And answer is minus log mod x plus 1 plus 2 log mod x plus 2 plus c. Yes, we got NCERT textbook answer. So what problems we are doing? Very good, Rajita. What problems we are doing? We are doing type 1 problems in integration by using partial fractions. You observe, we learned now, you observe, just now we integrated this. What is this? First thing, it is a proper rational function. Second one is denominator contains non-repeated linear factors. Then you know how to write this rational function into partial fractions. How? Look here, writing into like this. Now I'll find the values of a and b. Once I got the values of a and b, I'll substitute this a and b values in this equation only. Instead of integrating this is very easy, right? So look here, this I want to integrate. Actually, this same as this, I integrated this easily and I got the answer. How easy it is. Actually, type 1 problems are very easy in this integration by using partial fractions. Okay, let me do one more problem. Look this one. Integral of 3x minus 1 divided by x minus 1 into x minus 2 into x minus 3 dx. How you will come to know that for this problem we need to do integration by using partial fractions? First point, degree of numerator please. Degree of numerator is 1. What is degree of denominator? Degree of denominator is 3. Very good. So degree of numerator is less than degree of denominator. First one, it is proper rational function, correct? Okay, it is proper rational function. Second one, denominator contains linear factors. Is there any linear factor repeated? X minus 1 is repeated anywhere? No. X minus 2 repeated anywhere? No. X minus 3 repeated anywhere? No. So it is a proper rational function and denominator contains non-repeated linear factors. Very good, Juturo. Denominator contains non-repeated linear factors. So what is type 1? Look here, type 1. Type 1 is what? It is a proper rational function and denominator contains non-repeated linear factors. So this comes under type 1. Then we will write given proper rational function into partial fractions like this. Correct? We will write given proper rational function into partial fractions like this. Okay. Good. Now I'll take this 3x minus 1. Look here, this is a rational function. Proper rational function. Denominator contains non-repeated linear factors. So how it can be written as? It can be written as a divided by x minus 1 plus b divided by x minus 2 plus c divided by x minus 3. This is what we learned in the theory. As it is a proper rational function, denominator contains non-repeated linear factors. This can be split into partial fractions like this. Correct. Now, my intention is I want to find the a value, b value, c value. Okay. Look here, further I'll simplify this. What is LCM here? What is LCM here? LCM is, look here, x minus 1, x minus 2, x minus 3 is the LCM. I'll write it. X minus 1 into x minus 2 into x minus 3. Okay. That I written. LCM I written. Okay. Now what you will get here? A into, here x minus 1 is there na? X minus 1 is there. Other than this x minus 1, what is there here? That you write. You know all these things. No need of explanation of much. X minus 2 into x minus 3 plus b into, you look here, x minus 2 is there na? So in the denominator, other than x minus 2, what are there? You write those things. Okay. What you will get here? X minus 1 into x minus 3. Good. Plus c into, here what is there? X minus 3 is there. In the denominator, other than x minus 3, what are there? Those things you need to write. C into x minus 1 into x minus 2. Okay. That's good. Right? Now, you look here. This x minus 1, x minus 2, x minus 3, x minus 1, x minus 2, x minus 3 will get cancelled. Will get cancelled. What you will get? You will get like this. 3x minus 1 equal to, why to write all these things? We will copy. Check it. All plus minus came correctly or not? A into x minus 2 into x minus 3 plus b into x minus 1 into x minus 3 plus c into x minus 1 into x minus 2. Okay, we got it. Now, what I want to do, I want to find a value, b value, c value. That is my main target now. I want to find a value, b value, c value. To find a value, b value, c value, two methods are there. One is comparing the coefficients. Another one is easy trick. Suppose if you want a value, you make b value, c value 0. How? I'll tell you here. You want this a value. You want this a value. So you make this b value, c value 0. How to make b value, c value 0? In this, both the things, you observe that x minus 1 common is there. Here also x minus 1 is there. Here also x minus 1 is there. You put x equal to 1. When you put x equal to 1, this term will become 0 and this term also will become 0. Okay. Put x equal to 1 so that you will get a value. Put x equal to 1. Put x equal to 1 in LHS part also. Put x equal to 1. 3 into 1. That is 3. 3 minus 1. 2. LHS you will get 2 equal to. When I put x equal to 1. Here you observe this part. You observe this one. In this put x equal to 1. What you will get? A into. Look here. 1 minus 2. 1 minus 2 is what? 1 minus 2 is minus 1. Minus 1 into. Put x equal to 1 here. 1 minus 3. 1 minus 3 is minus 2. Minus 2. Okay. Here, what you will get? A equal to minus 1 into minus 2 is 2. Na? This 2 will get cancelled. So, a equal to 1. So, we got a equal to 1. A value we got. That's good. A value we got. Look here, one important thing. When I put x equal to 1, no, this will become 0. No need to write these things. Okay. Now, what I want? I want b value. If you want b value, you need to make this term 0. In these two terms, you observe any common term is there? X minus 2. X minus 2 is common in both, right? So what I'll do, I'll put x equal to 2. I'll put x equal to 2. Okay. Put x equal to 2. Put x equal to 2. Okay. Put x equal to 2 in this. 3 into 2, 6. 6 minus 1, 5. Put x equal to 2. 3 into 2, 6. 6 minus 1, 5. 5 equal to, when I put x equal to 2, this term will become 0. Okay. When you put x equal to 2, this also will become 0. Then you will get b value. Okay. So b into, look here, 2 minus 1, 1, 1. 2 minus 3. 2 minus 3 is minus 1. Minus 1. So from this you got b value. What is b value? B value is minus 5. Look here, this is minus 1. You can understand easily. B value is minus 5. Okay, we got b value as minus 5. Good. Now, a value I calculated. B value I calculated. I need c value. If you want to get c value, you need to make this a, b 0. How can you make a term, b term 0? You observe any common term is there in these two? Yes, x minus 3 is common in both. So you put x equal to 3. Okay, put x equal to 3. Put x equal to 3 here. 3 3s are 9. 9 minus 1 is 8. Okay, 8 equal to, put, when we put x equal to 3, this will become 0. This also will become 0. And this, okay, c into 3 minus 1. 3 minus 1 is 2. 3 minus 1 is 2 into, here look, c is 3 na, 3 minus 2. 3 minus 2 is 1 into 1. That equal to 8 by 2. C is 8 by 2. So c equal to 4. I got c value also. So this is the one I split it into partial fractions. Here I want to find a value, b value, c value. I got a value, b value, c value like this. Now you take this equation. This is actually what we have. This is actually what we have in the beginning from equation 1. Look here. I taken this as equation 1. Look this one. I taken this as equation 1. I written equation 1. Now I have a value, b value, c value. I'll substitute this a value, b value, c value here. Okay. What is a value? A value is 1. What is b value? What is b value? B value is minus 5. Okay. C value. What is c value? C value is 4. Okay. Actual thing is, I want to integrate this. By using partial fractions, I written this into like this. I written this into like this. Now, for me, it is very easy to integrate if this expression is of this form. Okay, come to the question. This is what you want to calculate, right? Integral of 3x minus 1 divided by x minus 1 into x minus 2 into dx. This is what you want to calculate. What you got here, this expression can be written like this. Okay, you take this one. Okay, into dx. I hope you are understanding. Actually, I want to integrate this by using partial fractions. I know that this can be written like this. So in place of this expression, I written this from this. I hope you are understanding. Now what I'll do, I'll integrate each and every term. Yes, start integrating. Integrate each and every term. Integral of 1 divided by x minus 1 into dx. Here look here, plus of minus is minus. While integrating this part, in the numerator minus 5 is there. Now minus 5 is constant. You take outside the integral. Minus 5 integral of 1 divided by x minus 2 into dx plus, here 4 is there now. 4 you take outside of integral. What is remaining? 1 divided by x minus 3 into dx. Okay. This equal to, now what is the derivative of x minus 1? Derivative of x minus 1 is 1. That means this integral is of which form? Integral of f dash of x divided by f of x dx. You know this. What is the formula for this? In model number 3 we practiced all these problems. Answer is log mod f of x plus c. Right? So as numerator is derivative of denominator, this answer we can write directly. What is the answer? Log mod x minus 1 minus 5 into, look here. What is derivative of x minus 2? Derivative of x is 1, derivative of 2 is 0, derivative of x minus 2 is 1. So derivative of x minus 2 is what? Derivative of x minus 2 is 1. As numerator is the derivative of denominator, we will write its answer directly. Log mod x minus 2 plus 4 times of, look here, derivative of x minus 3 is 1. Numerator is the derivative of denominator, so we can write it directly. That plus, look here, its derivative x minus 3 derivative is 1. So we can write its answer directly. Log mod x minus 3 plus c. So actual intention is I want to integrate this by using partial fractions. I written into like this so that I can integrate easily. Now you see we got its answer very easily. What we are doing? Integration by using partial fractions. Integration by using partial fractions, total 4 types are there. We are doing type 1 problems. What are type 1 problems? When given function is a proper rational function and denominator contains non-repeated linear factors. Okay. Now see this third problem. By seeing this question, how you will get an idea that how to do this. And one more important point here. In model number 5, if you observe this, in model number 5, at the end we did problems like this. Integral of px plus q divided by ax square plus bx plus c dx. In model number 5 we did this type of problems. You remember? What we will do? We will write px plus q as a into d by dx of denominator ax square plus bx plus c plus b, and we will find the values of a and b. We will proceed. We learned this in model number 5. At that time this procedure is without using partial fractions. Okay. But look here, this is px plus q divided by ax square plus bx plus c dx. This problem you can do with the help of that model. With the help of partial fractions you can do it very easily. Actually that px plus q divided by ax square plus bx plus c model is there, that is somehow lengthy. By using partial fractions this can be done very easily. To use partial fractions, first thing you need to identify is it is a proper rational function. Degree of numerator is less than degree of denominator. Yes, degree of numerator is 1, degree of denominator is 2. So it is a proper rational function. Second point, denominator contains non-repeated linear factors. Actually, I need to do one more step. I need to write one more step to understand this. Integral of 1 divided by, split the middle term. This 3x, you write it as a 2x plus x. Then this can be written as x plus 1 into x plus 2. Okay. Sorry, in the numerator what is there? Numerator 2x is there. Look here, if you multiply these two, you will get x square plus 3x plus 2 only. Okay, right. So first thing, it is a proper rational function. Second one, denominator contains non-repeated linear factors. So by using partial fractions, as it is a proper rational function and denominator contains non-repeated linear factors, then how you will write it as a divided by x plus 1 plus b divided by x plus 2. This is what we learned from the beginning of this class. This is the proper rational function. This is written into partial fractions. Why we written like this? Instead of integrating this one, integrating this is very easy. Okay. So my intention is what? I want to find a value, b value first. Okay. To find a value, b value, little bit of simplification we need to do. 2x divided by x plus 1 into x plus 2 equal to, what is LCM here? LCM is x plus 1 into x plus 2. What you will get? A times of x plus 2 plus b times of x plus 1. Look here, x plus 1, x plus 2, x plus 1, x plus 2 will get cancelled. Okay. Now what you will get? 2x equal to a times of x plus 2 plus b times of x plus 1. What I want to find? From this I want to find the values of a and b. To find the values of a and b we have two methods. One is comparing the coefficient, another one is some putting x values. Okay. What I'll do, I'll put x values here. What x value you need to put to get a value? If you want a value, you need to make this term 0. That means when x plus 1 equal to 0, what is x? X is minus 1. Okay, put x equal to minus 1 in this. When I put x equal to minus 1 in this, 2 into minus 1 is minus 2. Left hand side minus 2 equal to, when I put x equal to minus 2, sorry, when I put x equal to minus 1, you got minus 2 here, and this equal to a into, put x equal to minus 1 plus 2 is 1. So what you got here? You got a value is minus 2. I got a value minus 2. Okay. Now I need a b value. Put x equal to, if you want b value, then you need to make this term 0. To make this term 0, you equate x plus 2 equal to 0. X plus 2 equal to 0 means what is x? X is minus 2. Right? X is minus 2. Put x is minus 2. Put x is minus 2. Okay. Put x is minus 2. What you will get? In this, put x equal to minus 2. 2 into minus 2 is minus 4. minus 4 equal to, put x equal to minus 2, this will become 0. B into minus 2 plus 1. Minus 2 plus 1 is what? Minus 1. B is minus 1. Minus 1. So what is B you got? B you got 4. B you got 4. Very good. So we got this A value, B value. A value, B value we got. Now what I'll do, this is what is written, this improper rational function into partial fractions. Now I'll write that one only. Look here. Look here. Now I got A value, B value. What is A value? Look here, we got A value now. A value is minus 2. B value, what is B value? B value is 4. So I came to know that this expression can be written like this. Now I got A value, B value also. Look here, I written A value, B value. Why? Right. Now actually what is the thing? I want to integrate this one. I want to integrate this one. Okay. I want to integrate this one. Okay. Now what I got here, this equal to integral of this expression 2x divided by x plus 1 into x plus 2 can be written like this now. So in place of this, I'll write this one here. Okay. Into dx. I hope you are understanding. Now what to do? I need to integrate each and every term. While integrating this term, in the numerator minus 2 is there now. Minus 2 is constant. You write outside the integral minus 2 into integral of 1 divided by x plus 1 dx. While integrating this one, here 4 constant is there now. Write it outside, 4 into integral of 1 divided by x plus 2 into dx. Now this equal to minus 2 into what is derivative of x plus 1? Derivative of x plus 1 is 1. So in model number 3 we learn how to integrate this. This integral is of the form integral of f dash of x divided by f of x dx. If numerator is the degree of denominator, then its answer is log mod f of x plus c. We know that now. So what you will write here? This is log mod x plus 1. See, we used this formula so many times, right? Plus 4 into, look here. What is derivative of x plus 2? Derivative of x plus 2 is 1. Numerator is the derivative of denominator. So you can write its answer directly. What is its answer? Log mod x plus 2 plus c. Let me check once answer. 4 log minus 2 log 1. Yes, we got the textbook answer. Right? So I hope you are understanding these problems. Yes or no? And see this one. I am not doing this problem. I am not doing this problem. You need to do this. Just little bit of explanation I will give for this. Observe this one. Is it is a proper rational function? Is it is proper rational function? Yes. Degree of numerator is 1. Degree of denominator is 3. It is proper rational function. And you observe this denominator contains non-repeated linear factors. Denominator contains non-repeated linear factors. Yes, denominator contains non-repeated linear factors. So what do you know? This proper rational function can be written as, this can be written as a divided by x minus 1 plus b divided by x minus 2 plus c divided by x minus 3. Now you need to find a value, b value, c value. You see this problem is similar to this type. Look here, a value, b value, c value. I calculated. I want you to try this problem your own. Okay. So here I want you to calculate a value, b value, c value. Look here, I am writing answer also. I written a b, c values here. You will get like this. If you want, you take a screenshot of this and later try this problem. A is 1 by 2, b is minus 2, c is 3 by 2. A value, b value, c value, you will get like this. And then substitute a value, b value, c value. Integrating this expression is difficult. By using partial fractions, I written into this form. Now integrating this part is very easy. After integrating, you will get answer like this. I will take here. I think you can see now. You will get, again one more problem. You will get answer like this. I want you to try this problem because these are easy problem. No need to explain each and every problem. You can do these problems. You please comment below. Can you do it or not? Yes or no? Please comment. Yes. Very good. That's great. Please see question number 5. Observe this question. First point. Is it is a proper rational function or not? Degree of numerator 1. Degree of denominator 3. So it is a proper rational function. Its denominator contains non-repeated linear factors. Actually here I need to write one more step. 5x divided by x plus 1 into this x square minus 4 is there. Na? X square minus 4 can be written as x plus 2 into x minus 2. Very good. Very good. I want you to try and later you comment in this video whether you got answer or not. X square minus 4, you write it as x plus 2 into x minus 2, or x minus 2 into x plus 2, whatever it is. And this can be written as a divided by x plus 1, b divided by x plus 2, c divided by x plus 3. Then you will get ABC values like this. Here I want to tell you one point. Suppose you written this as a divided by x plus 1 plus b divided by x plus 2 plus c divided by x minus 2. Suppose if you write like this, you will get some ABC values. I can write like this also. Here x square minus 4 is then in the beginning I written x minus 2 x plus 2. Suppose I written like this. Look here, x minus 2, and look here, this is x plus 2. If I write like this, I will get different ABC values, but at the end somewhere either ABC or BC or CAB, you will get values like this only. 5 by 3 minus 5 by 2, 5 by 6. Okay, I want you to try this. Please try this. Please try this. ABC values you will get like this. Afterwards you integrate, you will get answer like this.